Hello and welcome back to the second segment. In the last segment, there was some technical issues, so I couldn't show the full working out of question number 5. So I'm going to start with question number 5 here. So the question says BCD and AFE are straight lines, right? So BCD is this one, and AFE is this one. These two are straight lines. Show that BCD is parallel to AFE. Now there can be two conditions which can make these two lines parallel. Say if this angle over here 30x minus 5 and 20x plus 45, if they are equal, and if 20x plus 45 and 4x plus 15 add up to 180 degree, then we can say that these two lines are parallel. Okay, so let's start with the first part, because we know in parallel lines alternate angles are equal, right? So let's start with 30x minus 5 equals 20x plus 45. Okay, so let's solve this equation to find the value of x. So I got 30x minus 20x is equal to 45 plus 5, which is 10x is equal to 50. X is equal to, both sides divided by 10 will give you 5. Now let's try to find out the value of these angles. So this angle over here, 20x plus 45, which is angle AFC, angle AFC, 20 times 5 plus 45, which will give you 145 degrees. Angle BCF is equal to 4x plus 15, which is 4 times 5 plus 15 is equal to 35 degrees. And angle DCF, which is this one, 30x minus 5, which is 30 times 5 minus 5, will give you 145 degrees. So we have noticed that this angle over here is 145, this angle is 35, and this angle is 145. So when I add angle BCF, which is 35 degrees, and angle AFC, which is 145 degrees, I get 180 degrees. That is one of the conditions of parallel lines, that co-interior angles add up to 180 degree. Also, we can see that this angle 145, angle AFC, is the same as angle DCF, and they are alternate angles. So we know that alternate angles in parallel lines are equal. Therefore, BCD is parallel to AFE. So you can use both the conditions, both the information that you have found out. So you can say angle AFC is equal to angle DCF. These are alternate angles and are equal. Therefore, BCD and AFE are parallel. Okay, so let's move on to the next question now. Question number 6. Now, question number 6, complete the table of values for x squared minus 5x plus 6. So first we need to fill in these two missing values. So when I take x as 1, if I take x is equal to 1, so I get 1 squared minus 5 times 1 plus 6, which will give me 1 minus 5 plus 6 gives you 2. And when x is equal to 5, so you get 5 squared minus 5 times 5 plus 6, which is 25 minus 25 plus 6. So you get 6. So we're going to plot these points in this graph. So 0, 6, which is here, 1 and 2, 2 and 0, 3 and 0, 4 and 2, and 5 and 6. Let's make it a bit more accurate. Okay. So that's my table of values done, as well as the plotting. Now I need to complete the graph. So when I'm doing the graph, okay, that's the graph. Now it says, by drawing a suitable straight line on the grid, find estimates for the solution of the equation x squared minus 5x is equal to x minus 7. Right. So let's first try to work it out like this. So we do y is equal to x squared minus 5x plus 6. Okay, now they said x squared minus 5x is x minus 7. So let's substitute this value into the equation. So I do y is equal to x minus 7 plus 6. Y is equal to x minus 1. So we're going to draw a straight line of this equation. So I take three values of x, 0, 1, 2. So I get minus 1, 0, and 1. Let's plot the points. So 0 and minus 1, 0 and minus 1 is here. 1 and 0 is here. And 2 and 1 is here. So now I'm going to draw a straight line using these 3 points. And you see this straight line has crossed this graph at certain places. So one is here, another one is here. So let's take the reading of the x coordinates. So it's 1 point, it's about 4 units before 2. So this is 1.6. That's one value. The other one is 4.5. So x is equal to 1.6 and 4.5. Okay, so that is the solution to this graph question. Standard form. The table shows the volumes in kilometer cube of the 4 oceans. Write down 7.18 times 10 to the power of 7 as an ordinary number. So that is 7.18 times 1, 2, 3, 4, 5, 6, 7. So what's going to happen? The digits are going to move 7 units to the left, right? So you got 7, 1, 8 followed by 1, 2, 3, 4, 5 zeros. So which is 71 million 800,000. Calculate the total volume of these four oceans. Now here what I tend to do is try to make all the powers the same. So this one, instead of 1.88 times 10 to the power of 7, I can write 0.188 times 10 to the power of 8. Now this is not in standard form, but I'm doing it just for the sake of making the powers the same. And the last one can be, I leave these two as they are, and this one will be 0.718 times 10 to the power of 8. Now, if I want to find out the total volume of these four oceans, I'm going to do 0.188 plus 3.10 plus 2.64 plus 0.718 multiplied by 10 to the power of 8. So let's work it out. What do we get? 0.188 plus 3.10 plus 2.64 plus 0.718 gives you 6.646. 6.646 times 10 to the power of 8. The third part of the question says the volume of the South China Sea is 9,880,000 kilometer cube. We have to write it in standard form. So we just keep the first digit as it is. So it's 9.88 times 10. Now obviously this 9.88 multiplied by 10 to the power of 6 will give you your answer. So 10 to the power of 6. Reason being, I have moved the digits 1, 2, 3, 4, 5, 6 digits to the right. Okay, next question, question number 8. Okay, so the diagram shows an isosceles triangle. The area of the triangle is 12 centimeters squared. Work out the perimeter of the triangle, give your answer correct to 3 significant figures. One of the things we know about isosceles triangle is that if I draw a perpendicular line from the top vertex to the base, it's going to split the base into 2 equal parts. Okay, so the area of the triangle, so we need to find out the height of this triangle in terms of x. So that part is 2.5 centimeters. That is also 2.5 centimeters. We don't know what the height is. So let's work out the height using Pythagoras theorem. So we can write x squared plus x squared is equal to 2.5 squared plus the height squared, right? Now the height squared is then x squared minus 2.5 squared. That is the height of the triangle. So the height of the triangle will be square root of x squared minus 2.5 squared. That is the height of the triangle. Now we know the area of the triangle is 12 centimeters squared. So we know that half base times height is the area. So we can do half. What is the base? Base is 5 centimeters times the height x squared minus 2.5 squared. That is equal to 12. Right? So what now we're going to do is we're going to try and solve the equation. So half times 5 is 2.5 or 5 over 2. Okay, let's write it as 2.5 times square root of x squared minus 2.5 squared is equal to 12. Now take the 2.5 to the other side or divide both sides by 2.5. So I get square root of x squared minus 2.5 squared is 12 over 2.5. Okay, now I'm going to square 12 over 2.5 is 4.8. Now I'm going to square both sides. So I get x squared minus 2.5 squared is 4.8 squared, which is going to give me 23.04. Now I'm going to add 2.5 squared to both sides. So I got x squared is 23.04 plus 2.5 squared coming from here to here. So x squared is equal to 29.29. So x is going to be square root of 29.29, which is giving me 5.41, correct to three significant figures. Write it a bit clearly. So the perimeter of the shape is now going to be is going to be 5 plus 5.41 plus 5.41, which is 15.82. Correct to three significant figures, 15.8 centimeters. Move on to the next question. Question number 9. Okay, this is a question on cumulative frequency. We're going to first fill in the cumulative frequency table. So between 0 to 10, there are 3 cycles. Between 0 to 20, so 0 to 20, it's 3 plus 16, 19. Then 3 plus 16 plus 24, which is going to be 43. Then you have got 53. You're adding each frequency as you go on. 58 and 60. So that's the first part done. Pretty simple, straightforward. And what we are doing here is we are just finding the cumulative frequency. Now we're going to plot these values on the graph below. Okay, so our values were 3, 19, 43, 53 and 60. So let's start plotting them. We are going to take these values as the x and these values as the y. So our first coordinate is 10 and 3. So you go 10 and 3. My second coordinate is 20 and 19. My third one is 30 and 43. 30 and 43. And 41, 2, 3 here. My fourth one is 40 and 53. 40 and 53 here. Then I've got 50 and 58, 50 and 58. Finally 60 and 60. So what I'm going to do now is I'm going to draw a freehand smooth curve joining these coordinates. So this is my cumulative frequency diagram drawn. Now they're saying use your graph to estimate an interquartile range of the speeds. So let's say we've got 60 values. So the interquartile range will be the 45th value, the upper quartile, or also known as quartile 3, and the lower quartile, quartile 1, is 60 divided by 4, which is the 15th value, right? So we're going to take the 15th value. 15th value will be here. Fifteenth value is here, and the 45th value is here. Okay, so let's take the readings. This is 2019 here, and here you have got 31, 32, 33. So the interquartile range will be 33 minus 19, which is equal to 14, and that's your interquartile range, right? 14 kilometers per hour. Right, let's move on to question number 10. The point C is a triangle ABD. Point C lies on BD. Point C lies on BD. Good. And AD is 13 centimeters. BC is 8 centimeters. So the whole thing is not 8. This part is 8 centimeters. Angle ADB is 90 degrees. And angle CAD is 20 degrees. Okay, so calculate the size of angle BAC. We need to find out this angle. All right, so what I'm going to do is I'm going to treat these as two separate triangles. Okay, so first I'm going to work with the smaller triangle ACD. So I'm going to work with the smaller triangle. Okay, so that angle here is 20 degrees. This is 13 centimeters, and I'm looking for the missing side. So that's my hypotenuse, adjacent, and opposite. So if I'm looking for the opposite, I'm going to use O and A. I'm going to use tan. 20 degrees is opposite over adjacent. Or opposite is equal to 13 times tan 20 degrees, which is going to give me 4.73, correct to 2 decimal places. So this part is 4.73 centimeters. Now what I'm going to do is I'm going to consider the whole triangle now. So let's imagine that triangle is not there. Let's work out this angle. So we have got the hypotenuse, the adjacent, and the opposite. So what I'm going to do is I'm looking for, let's say the angle is called X. So I'm finding tan X is equal to opposite over adjacent. BD, the length of BD, which I have just worked out, is equal to 8 plus 4.73, which is 12.73. Okay, so this is going to be 12.73 over 13. So the value of X is going to be tan inverse 1273 over 13. Let's find out. Shift tan and I'm getting 44.40 correct to one decimal place. I'm getting 40. So that is the whole angle X. Now, the interesting part here is part of that angle is 20 degree. We're looking for the missing part. So, angle ABAC is 44.4 degrees minus 20 degrees, which is 24.4 degrees correct to one decimal place. So that's where we conclude our second segment with the question number 5 to question number 10. In our third segment, we'll be working from question number 11 to question number 15.